Hi Andy, good morning. So, welcome to machine learning. Today, let us discuss what are the different output models. So, totally we have four models, right? Let me just write. So, machine learning can be divided into two parts. Be divided into two parts. One is called supervised learning. And another one is unsupervised learning. And this supervised learning can also be divided into again two parts. Classification. The second one is regression. Similarly, the unsupervised learning also can be divided into two or three parts. They are clustering. Dimensionality reduction. And the last one is association mining. This is how our machine learning, the total book specifies only these things. These are called how to learn machine learning language. Now, on what basis, what are the output models? What are the output models from this? Let us see that. Similarly, what are the output models we have? So they are broadly categorized into four. They are geometric models, probabilistic models, logic models, and grouping and grading models. There are four types of output models. One is geometric model, probabilistic model, logic model, and last one is grouping and grading model. So this is we have already seen geometric model and probabilistic model. Let us see now the other two, what is called logical model and grouping model. What are logical models? Logical, already we all know what do you mean by logical. So whenever we say logical, the output of logical is true or false, Boolean. Mainly this logical is used to construct rules based model. Rule based model. Rule based model means a rule is placed like if, if. So the total number of leaves for a staff member in a college is 12 per year. So then how rule comes here? If the number of leaves of a particular staff member is equals to this 12, then there is no loss of pay. If otherwise, there is a loss of pay. So these type of rules are called logical models. And see, you can see here. And here we represent this with the feature tree. Feature tree. And if the rules are organized in a tree fashion, then it is called feature tree. Use a logical expression to divide the instance space into segments and hence construct grouping models. That we'll see in the grouping and grading models also. If the leaves represent the classes, then it is called a decision tree. Decision tree. Normally, rectangle boxes are used to represent classes and real values. And the circles are used to represent features. Right. A logical expression is an expression. A logical expression is an expression that returns a Boolean value. That always returns a Boolean, that is a true or false outcome. Once the data is grouped using a logical expression, the data is divided into homogeneous groupings for the problem we are trying to solve. Homogeneous groupings means all true instances will come at one side, all false instances will come at follow at one other side. That is called homogeneous. Okay, recommend 20 homogeneous groupings. This is called homogeneous grouping. A logical expression is again an expression that returns a Boolean value, true or false. Once the data is grouped using this logical expression, the data is divided into homogeneous groupings for the problem, right? Now, for instance, we can say check here. For example, there is actually Viagra. If a word like Viagra appears in a mail, that is considered to be spam. That is considered to be spam. Now we write a simple if like this. If Viagra, then spam is equal to 20, ham is 5. If no Viagra, if not Viagra, then we consider whether it is a lottery. Is there any word called lottery? If the answer is yes, we say spam is 10, ham is 5. And if there is no lottery word, then we say spam is 20, ham is 40. So this is represented using if. Let there are two words, maybe write Viagra and lottery, check whether they are present in our email or not. If Viagra word exists, no doubt it is spam. This is also shown here. Here on x-axis we have taken Viagra, on y-axis we have taken lottery. So if at all, if there is 0 means there is no Viagra, 1 means there is a Viagra word. So if there is a Viagra word called as Viagra, automatically spam is 20, ham is 5. Whether lottery exists or not, we don't need to check. So this is called, no, this is how we represent logically. Logically. And if you see, if Viagra is 0, then if lottery is 0, we say spam is 20, ham is 40. And if Viagra is 0 and lottery is 1, we say spam is 10 and ham is 5. So this is called, this is the table, uh, this is the table visualization. Our visualization we are talking about always visualization. So if instead of looking at if, so if we look at this particular table, so hope uh, this is more visualized, visually looks easier. See here, very simple. If Viagra is one, no need to check this particular lottery. The spam is 20. If Viagra is 0, then we check. If lottery is 1, spam becomes 10. And if not, then the spam becomes 20 and ham becomes 40. As simple as this. So next, the feature list. A binary feature tree that branches in the same direction. This is nothing right to left or left to right. Something like this. This is called feature list. If else ladder is called feature tree. Nothing more than that. The leaves of the tree could be labeled from left to right as ham, spam, spam, something like that. Normally, the leaves are classes, class names labeled with class names. For example, if Viagra is 1, then class Y is spam. Else, if lottery is 1, then class Y is spam. Else, lottery is 0, then class Y is ham. And even if this bonus may have again an else part, that else part can again be ham, something like that. From here, now complex expressions also can be used here, my dear friends. Complex expression means see, complex expressions you already have learned all these things. Conjunction, logical and, which is denoted by and symbol. Logical and, two or more logical expressions can be combined. Two or more logical expressions can be combined using this and, logical and. Similarly, disjunction. Two or more logical expressions can be combined by or. Implication. That is, if this happens, this happens. If this don't doesn't happen, this won't happen. Such things are defined by, denoted by arrow mark. So, and the negation, which is denoted by this. So, you all might be knowing that. So, we have logical end, and logical not. So, logical end and logical or. No, how logical and gives you true. True and true gives you true. True and false gives you false. False and true gives you false. False and false gives you false. If now we can say definitely if both are false, then only the output is false. Otherwise, they always true. So true, true gives you true. So in all other cases, if one of the input is false, the output is false in logical end. Similarly, what is the logical OR? Logical OR means if all if one of the element is true, the output is true. That is true, true, true or true, true, true or false, true. False or true, again true. Here you can say if all the elements, if all the inputs are false, then only the output is false. All other conditions, we can definitely say it is true. This is called OR, logical OR. And then, so, right, what do you mean by negation? Negation, if true, then the output is false. If false, the output is true. As simple as this. Now, you can also see example if bonus is 1 and or lottery is 1. See here, if bonus is 1 or lottery is 1, then class Y is equal to spam. See, this is Viagra. You can see bonus and Viagra are interchangeably used. So if Viagra is 1 and lottery is 1, then class Y is equal to spam. At least, if at least these two, at least one is 1, see this, my dear friends. If at least one is 1, then we say it is spam. Otherwise, ham. Otherwise, ham. Otherwise means either bonus is 1, neither bonus is 1, or neither Viagra is 1, nor lottery is 1. Then we can definitely say it is ham. It is a good. If bonus equal to 0 and lottery is 0, then class Y is equal to ham. Else class Y is equal to spam. So both represent the same thing. Example 1 represents the same thing. Example 2 represents the same thing. We can also represent the same model as an unnested rules. If bonus equal to 1, then class Y is equal to spam. If bonus equal to 0 and lottery is equal to 1. If bonus equal to 0 and lottery, then class B is equal to spam, else ham. If bonus equal to 0 and lottery equal to 0, then class Y is equal to ham, else spam. So this is how no logical and or not are used to define logical models. There are mainly two kinds of logical models, my dear friends. One is uh, tree learning and rule learning. Tree learning and rule learning. Tree learning, tree learning and rule learning are top-down fashion. Top-down approach, you might have learned the top-down approach and bottom approach in your structured programming and all. So use the same approach to supervise learning. An algorithm that works by repeatedly splitting a problem into small sub-problem is what computer scientists call a divide and conquer. Divide and conquer. A big problem is given to you to solve. In order to solve that particular problem, we divide that problem into small problems. Small problems. We divide the given problem into small problems. And we write a module for each sub-problem. And later, we combine all these modules into one. That is called divide and conquer. Might have learned this particular thing in uh, so anyhow, whatever it is, rule model. It follows separate conquer approach, and it consists of a collection of implications or if then else rules. If then else rules. Rule model follows some reasoning. This is very important, my dear friend. Reasoning. Always rule models and tree models, unlike probabilistic model and geometric model, it also gives you reasons why this particular prediction is made. The reasons for predictions. Our machine learning is all about predictions. Is all about predictions, my dear friends. It always gives you. It takes the world. It considers the world. It analyzes the world, and it gives you a summary report or predictions, predictions that might be true, that may be true or may not be true. But what we are trying to develop models by which it gives you a 80% perfect result, 80% perfect result or 70% perfect results. For these things, we are following all these things. So tree learning, we follow divide and conquer, and it can be seen as a particular type of rule model where the if parts of the rules are organized in a tree structure. Tree structure. This is called logical model. A logical model provides explanations for their predictions, unlike the geometric and probabilistic model. See, overlapping rules, what is called inconsistent, what is called incomplete, and what is called overlapping of rules. Let us see now. See, for example, if you see here, uh, See, overlapping. Consider the following rule. If lottery, if lottery is equal to 1, then class Y is equal to span. And the second rule is, if Peter is equal to 1, then class Y is equal to ham. See, as you can see in this figure, see what he says, lottery, Peter, 0 and 1. If Peter is 1, then class Y is ham. This is ham. If lottery is 1, this is span. And you can see clearly there is some overlapping here. There is some overlapping here, my dear friends. This is called overlapping. This particular thing is called overlapping. That is, you have not defined rules in such a manner that see, this overlapping occurred. Not only that, see, if lottery is 0 or Peter is 0, inconsistent. See, here you have not defined anything. So this type of rules are called as inconsistent or incomplete and overlapping. Overlapping means the same condition for the same condition. So two or more condition rely the same, use the same space, we call it as overlapping. Overlapping is okay, no problem. It is not bad, but this inconsistency, incomplete is very bad for a model. This is called logical model. Logical model. So logical model, let me just revise what is called logical model. Logical models are mainly used with logical expressions, my dear friends. Logical expressions. Here, a flowchart or a logical diagram is drawn, and see here, all boxes are represents boxes represent classes, boxes represents classes, and the rectangle shapes represent the features. And see here, you can also see a diagram here where in the on the x-axis we have taken one word, and on the y-axis we have taken the second word, and we can clearly see, uh, come to a conclusion how it is. Now features list. So all these features list are written like features and decision. If written like this, which is called features list, and we can have an example also. And we have uh, logical and, logical or, if then, negation. So all these things are used to combine two or three logical expressions. We have here uh, rule models and tree models. Rule model means if they are made with if then else. If then else. Tree models means if the same if then else are written with a tree model, such is called tree model. Remember, this is a tree model. This is a tree model, and this can be said as a if model, decision tree. So, and inconsistent is very important, overlapping. So in this particular example, we can see here very clearly what do you mean by inconsistency, and what do you mean by incomplete, and what do you mean by overlapping. And the next one is grouping and grading. The next one is grouping and grading. Grading. What do you mean by grouping models and grading models? By the name itself, grouping means homogeneous grouping. What do you mean by homogeneous grouping? So all alike instances are grouped into one. That is called grouping. What do you mean? How do you grading? Grading means not exactly. Grouping means exactly. Homogeneous is called grouping. Grading means similar items. Similar items. See, know what to know better. So know what to know better. Grading slightly different, small difference is there between grouping and grading. Grouping means all must be a type, one type, like integers. All integers can be grouped into one. All real numbers are grouped into one. All characters are grouped into one. All strings are grouped into one. Grading means if there's some data is there, divide numeric. All numerics are graded. Numeric means so it may be integer, it may be real value, something like that. And all other integer, all other non-numeric are graded separately. See, this is called and grading. See, but both are used. No, both are used to in models, right? The key difference between these models is the way they handle the instance space. Grouping models do this by breaking up the instance space into groups or segments, the number of which is determined at the training time, training day, training. See, again, grouping and grading. Grouping, see, instance space is grouped into smaller segments based on a criteria, based on a criteria. That is called grouping. Whereas, so for example, you can see here a map of some of the models that will be considered in this portal book. Models that share characters are plotted closer together. Logical models to the right. Logical models, tree models, rules, association, all these three are called logical models. Logical. Geometrical models on the top. See, linear classifier, linear regression, KMN are called geometrical models. Geometric models. Linear classifier. So classification, regression, supervised classification, regression are normally represented with geometric models. And probabilistic model are grouped into on the bottom of the. This is called probabilistic models. Probabilistic models, and uh, and these are called grading or grouping models. These are called grading and grouping models. So this is called grading and grouping models. So this is how grading or grouping can be done. Grading or grouping can be done. We'll see this. Grouping model. The main emphasis of training a grouping model is that on determining the right segment so that we can get away with this very simple labeling at the local segment level. See, a good example of grouping models are the tree-based models we have just considered. They work by repeatedly splitting the instance spaces into smaller subsets. Grading, on the other hand, do not employ such a notion of segments can divide చేయటం అనేది ఉండదు. Rather than applying very simple local models, they from one global model for the instance. Example, support vector machine will be learning in the next step, and other geometric classifiers are examples of grading models. Linear classifiers are also examples of grading model. The distinction between grouping and grading model is relative rather than absolute, and some models combine both the features. Both the features. This is good. Now you can see all what are all we have learned. Grading. The grading a bit, it is called logical. A lot, it is called geometric. See, if grading to be done on a bitwise, it is called logical. A lot, we use geometric mode. And if logical, yes. And if it is supervised, then we go for association rule mining. If not supervised, if supervised, we go for tree and rules. And not so much logical. It is not so much logical. Then we go for the probabilistic mining, that is called navy base. Geometric model, not completely geometric, Then we will go check whether supervised or not. If not supervised, we go for JMM. We'll be learning in the next coming classes. And if supervised, yes, simple vector machine. Then see if geometric grouping not possible, linear classifiers and some grouping can be done, then we say k-means and KNN. This is how, so in this textbook, we will be completely going with all these models. Hope you understand. This is called grouping and grading. See, we have learned today, so what are called output models of our machine learning. Output models of our machine learning. There are four models, my dear friends. One is geometric model, two probabilistic model, three logical model, and four grouping and grading models. So in logical model, see in logical model, we completely go with if if then else, if then else, if then else. So here also we can divide this logical into two parts. One is called rule model and tree model. This is called rule model. Rule model. This is called rule model, and this is called tree model. Of course, whatever it is, this is only visualization. If you see visually, this is called rule model, and this is called tree model. Tree model, and both follow if then else only. Both follow if then else only. And we have, of course, we have seen conjunction, disjunction, implication, negation. So you all might be well versed with all these things. This is called rule models and tree models. But this is very important. Is see if you extract or if you design some rules and regulations, they should not be overlapping can be done, but they cannot be inconsistent or incomplete. See here, there are only two rules. If lottery equal to 1, then class Y is equal to spam. If Peter is equal to 1, then class Y is equal to ham. See, if you see here, Peter is 1 and lottery is 1. And for the same set, some say ham, some say spam. This is not correct. So if Peter is 1, it is saying spam. If lottery is 1, it is paying spam. So see, this is ham and spam. This is ham and spam. How is it possible? It is not possible. Such overlapping cannot be done. And similarly, inconsistency is there. See, if lottery is 0 and it is 0, there is some inconsistency. So this is called no rule based and